Alright, this is part 2 of our chapter 11 part 2 review. This is going to go over empirical and molecular formulas. Now remember, with empirical and molecular formulas, you have to come up with the empirical formula before you can come up with the molecular formula. And I know in your minds, you think it's almost a whole page of work, this is too hard. But also remember that it's not difficult. There are plenty of steps to it, but it's not difficult. You can all do this. You've all done it in class. So let's go ahead and get started. It's going to work the same way as the first part. I'm going to give you a problem, and I want you to work it out fully. I want you to pause the video. I want you to work it out fully, and I want you to check your work with what I'm doing. That way you know where you messed up and where you can fix it for tomorrow's test. If you just watch me do it, it's probably not going to have the same effect. Alright, so here we go. Okay, so here's the problem. And I want you to work out the whole thing. Not just number 1, not just the first part, but I want you to work out 1 and 2. I want you to do what is the empirical formula of a molecule containing 65% carbon, 5.5% hydrogen, and 29.0% oxygen. And then once you find the empirical formula, go ahead and find the molecular formula, because they give you the molar mass is 110 grams per mole. So go ahead and try this. I went ahead and put up excuse me, I went ahead and put up the formula chart for you. That way you have it to do it. Okay, now this is going to take me a few screens to show you how to do it. So just bear with me and we'll get through it. Empirical formula. There are many steps to find the empirical formula. The first step is the easiest step. In the problem, they give you percentages. What we need to do is we need to take those percentages and just change them to grams, not with math, just simply changing the percent sign to grams. And the reason why we're going to do that is because of this one thing. Percentages add up to 100%. So what we're going to do is we're going to base our sample on 100 grams. So if we have 100 grams, then we should have 65.5 grams of carbon, 5.5 grams of hydrogen, and 29.0 grams of oxygen. That's what we're basing it on. So 65.5 grams of carbon, 5.5 grams of hydrogen, and 29.0 grams of oxygen. Okay? So now we have our 3 masses, our 3 grams. So what you need to do with those is you need to change them to moles. Okay? I should have enough room on this screen to do 2. So that's what we're going to do. In order to change it to moles, we have to cross out grams. So my 1 mole has to go on top. The number that goes on bottom is the number that we come up with after looking on the periodic table. So you look on the periodic table, you find carbon. Carbon's molar mass is 12.001 grams. Our grams cross out, so all you have to do is take your top, multiply those numbers, divide it by your bottom number. After you do that, the answer that you should come up with is 5.45 moles of carbon. Then you're going to do the same thing to hydrogen. 1 mole goes on top. You look on the periodic table, find the molar mass. The molar mass of hydrogen goes on bottom. You cross out your grams. You multiply everything on top, divide by everything on bottom, and you will get not a 6. Sorry about that. Definitely was a 5.46 moles of hydrogen. And really we only need 2 sig figs for that. So this would actually be 5.5 moles of hydrogen. Okay? We're going to do the same thing to oxygen. Oxygen has a mass of 29.0 grams in our problem. To change it to moles, our mole goes on top. And then on bottom, what we need to do is we need to look it up on the periodic table. We look it up on the periodic table and we find that its molar mass is 15.99 grams. Cross out our grams, multiply everything on top, divide by everything on bottom, and you should get 44.999. We only need 3 sig figs, so this turns into 45.0 moles of oxygen. Okay, so now that we have the number of moles of each of those elements, I'm going to rewrite them now. Carbon was 5.45 moles. Hydrogen was 5.5 moles. And oxygen was 45.0 moles. Now what you need to do is you need to figure out which one of these numbers is the smallest. The smallest is this. So now you're going to divide all of these by that smallest number. So we have 1 mole of carbon. Remember, you want it to be rounded to either the nearest whole number or the nearest whole 0.5 number. So whenever we divide this, whenever we divide our hydrogen, we get pretty close to 1 mole. Okay? And then we have to do the same thing to oxygen. And whenever we do that, we get 8.2, which would round to 8. Okay? So now we have to use these numbers that we just got, and those are going to be our subscripts. So our empirical formula is C1H1O8. Does not look like an 8. Let's fix that. That is the empirical formula. Now let's talk about the molecular formula. With the molecular formula, you have to have a molar mass given to you. The molar mass that was given to you was 110 grams per mole. This is the experimental. We have to divide that by the molar mass of our empirical formula. So carbon on the periodic table, is 12.011 grams. We have 1 of those. Hydrogen, 1.008 grams times 1. And then oxygen is 15.999 times 8. You would add that up. Let me write this real fast. Anyway, you would add all 3 of those up, and you would just simply divide your experimental mass by that molar mass. And that molar mass is 141.011. Okay? Okay. Nobody's perfect. I have made a mistake. And I 100% apologize for that, but this is a good mistake because I can show you what to look for to know if you've made a mistake. When the experimental number on top is less than the molar mass on bottom, that should raise some red flags and show you something's not right. Let me go back and look. So what I did, or what I'm going to do, is I'm going to look at these numbers here, and I'm going to compare them. And I noticed that carbon and hydrogen are really close, and oxygen is really far off. So I went back here, and I noticed that whenever I actually divided these,